Picture this. You've just finished an absolutely massive dinner. Like maybe it's a holiday feast, or maybe you just went a little too hard at your favorite Italian place.
Oh, yeah. We have all been there.
Right. So you are physically stuffed. You're pushing your chair back from the table. You're taking a deep breath, and you're thinking you couldn't possibly take another bite of anything.
Not a single bite.
But then, almost like magic, someone opens a box of fresh pastries. Or, I don't know, maybe you just catch a glimpse of a brightly lit bakery window on your walk home.
Yep.
Or see a high-definition photo of a brownie on a delivery app.
And suddenly, impossibly, you have room.
Exactly. The craving hits you like a freight train.
It's crazy because it completely defies biological logic. I mean, you have just flooded your system with calories, your stomach is physically stretched, hormones are actively signaling satiety to your nervous system.
Yeah, your body is yelling that it's full.
Right. And yet, a simple visual cue completely overrides millions of years of evolutionary fail-safes.
It's so weird. So we're pulling from some really fascinating source material today to figure out why this happens to you. It's this insightful article from Psychology Today, written by Dr. William A. Hazeltine.
A really great read, by the way.
It really is. And he examines a revealing 2025 study published in the journal Appetite. The researchers basically set out to map the exact neurological mechanism that forces us to make room for dessert.
They wanted to find the exact glitch in the brain.
Right. Okay, let's unpack this, because the fundamental premise here completely flips the script on how we view self-control.
It really does.
We're conditioned to think that reaching for that post-meal brownie is a failure of willpower, like a moral failing. But Dr. Hasseltine and the study are showing that it's not a failure of character at all.
No, not at all.
It is a highly specific, measurable biological glitch in how your brain processes modern visual cues.
Yeah, and to understand the glitch, we really need to look past the basic mechanics of hunger. Like, we all know that when the body needs fuel, hunger signals rise.
Sure, you feel your stomach rumble.
Right. And when you eat, those signals are supposed to turn off. It is a closed-loop system. But we have to factor in the sheer speed at which visual processing interacts with the brain's reward centers.
So it's about our eyes, really.
Exactly. In human beings, and primates generally, our visual system is incredibly dominant. I mean, we evolved color vision in large part to spot ripe fruit against green foliage.
Oh, that makes sense.
Yeah, seeing a calorie-dense food source was the ultimate survival jackpot.
So the visual cue itself became hardwired to the reward. I always think of our body's satiety system like a thermostat in a house.
Oh, that's a good analogy.
Right. You set the temperature to 70 degrees, the heater runs until the room hits 70, and then the sensor shuts the whole system down.
And your body does the exact same thing with food.
Exactly. You eat until the caloric temperature is reached, and the stretch receptors in your stomach tell the brain to shut down the hunger drive. But looking at a picture of a brownie on your phone is like someone walking up to the thermostat and holding a later directly under the sensor.
Yeah, the ambient room is perfectly fine, but the sensor is getting flooded.
Right, by this localized, intense signal that completely confuses the system. So I have to ask, if our biological gas gauge works so well, why does a picture of a brownie override the system?
Well, if we connect this to the bigger picture, you have to look at the mismatch between the environment that built our brains and the environment we actually live in today.
Meaning, like, evolutionary history.
Exactly. Biology prepared us for severe scarcity. It did not prepare us for delivery apps, targeted ads, or the midnight glow of a refrigerator.
Right. There were no billboards on the savannah.
No, there weren't. A visual food cue, like that digital picture of a brownie, provides 0 actual calories. But over thousands of generations, your brain learned that visual cues predict massive caloric rewards. Today, our modern world is just saturated with these cues, and they're heavily engineered by food marketers to trigger your survival instincts. You are constantly bombarded by signals telling your ancient brain that you have just stumbled upon a rare, life-saving honeycomb.
Wow. Which brings us to how researchers actually prove this is happening under the hood. I want to look really closely at the methodology of the 2025 experiment from the journal Appetite.
Yeah, it's a clever setup.
They gathered 90 university students, brought them into the lab in a fasted, hungry state, and had them rate a variety of foods to establish a baseline of what they actually desired.
The researchers wanted a highly accurate map of each participant's individual preferences, so they weren't just guessing what people liked.
Right, they personalized it.
Exactly. And once they identified 2 similarly appealing foods for each person, they moved into the critical phase of the experiment, This is a process known in behavioral psychology as devaluing the food.
Devaluing, which
Mm,
in this specific context means they essentially force-fed them.
pretty much, yeah.
Like, if a student highly rated potato chips, the researchers provided an unlimited supply and instructed the student to eat until they physically could not tolerate another bite.
Right. They pushed the participants to a state of complete sensory-specific satiety. They drove the motivational value of that specific food right into the ground.
So they were totally sick of the chips.
Absolutely. After the eating phase, the students were asked to use subjective sliding scales to rate how much they wanted the food they had just eaten, as well as the other food they had rated highly but hadn't eaten yet.
And let me guess, the desire for the chips tanked.
As expected, yeah. The subjective desire for the consumed food plummeted to near zero. The participants clearly indicated, both verbally and through subsequent behavioral choices, that the food had just lost its magic.
Okay, wait, I have to push back on the premise here for a second, though.
Sure, go ahead.
Wait, so the students ate until they were stuffed and then reported they didn't want the food anymore? Doesn't that just prove the system works perfectly? Why is this a problem?
Because those self-reported sliders and deliberate behavioral choices only capture the output of the conscious mind.
Oh, I see. So it's only half the story.
Exactly. It measures the prefrontal cortex, the logical reasoning part of your brain that synthesizes all the incoming data, including the stretch receptors in the stomach, and concludes, hey, we have had enough.
But the appetite researchers were not satisfied with just conscious reporting.
No, they weren't. While the students were looking at these images and filling out these sliders, they were wearing EEG caps. The researchers were recording rapid electrical activity directly from the scalp.
Ah, so they're measuring the electrical impulses that happen before the conscious mind even has time to formulate an opinion on the slider.
You got it.
They are looking for a contradiction between the raw, automatic data and the conscious thought.
Exactly. They were looking for a specific neurological phenomenon called an event-related potential, or ERP.
Right, an ERP.
Yeah, an ERP is a measured brain response that is the direct result of a specific sensory, cognitive, or motor event. And in this case, they focused on a component called reward positivity, or REVROP.
Okay, let's break down reward positivity for the listener because I feel like this is the crux of the whole glitch.
It really is. So reward positivity is a lightning-fast, entirely automatic surge of electrical activity. It originates deep in the brain's reward centers, primarily involving the striatum.
And when you say fast, you mean like instantly.
Incredibly fast. We're talking within 250 to 300 milliseconds after seeing a stimulus.
Wow.
Yeah, it is the brain's instant subconscious evaluation of a potential reward. It's that initial spark of desire, firing long before your conscious prefrontal cortex has time to analyze the situation.
So early in the experiment, when the students are starving, showing them an image of potato chips causes a massive spike in reward positivity.
Naturally.
The striatum sees the chips, recognizes a high-calorie survival mechanism, and just floods the system with electricity saying, go get that.
That is the baseline, yeah. But the turning point of the study happens after the devaluation phase.
When they are stuffed.
Exactly. The students have eaten the chips until they are practically sick. Their conscious prefrontal cortex is firmly stating no more. Then the researchers flash the images of the exact same food on the screen again while monitoring the EEG.
Here's where it gets really interesting. Because logically, you would assume that because the body is full and the conscious mind is rejecting the food, that the brain's initial electrical response would flatten out.
Right, that would make sense.
But the electrodes showed the exact opposite. That fast, automatic spike of reward positivity still triggered. It didn't shrink at all.
Not even a little bit.
The electrical signal firing in their brain upon seeing the picture of the food they were sick of was virtually identical to the signal that fired when they were starving.
What's fascinating here is the sheer independence of that early neural response.
Yeah, it doesn't care about the stomach at all.
It means a remarkably fast, automatic part of your brain continues to light up and scream more in a split second, reacting to the visual cue as if it still carries a massive survival reward. It completely ignores the fact that the stomach's physical stretch receptors and the circulating satiety hormones are screaming that the body is full.
It's like the conscious mind, the prefrontal cortex, is the manager of an exclusive nightclub.
Okay, I like where this is going.
The manager is holding the clipboard, looking at the fire code, looking at the capacity, and saying, we are totally full, lock the doors, nobody else gets in.
Right.
But the striatum, that fast-reacting reward center, is a rogue bouncer working the velvet rope. And this bouncer keeps seeing VIPs walking up.
And the VIPs are the food cues.
Exactly. The picture of the brownie, the brightly colored delivery app logos, the bakery window, and the bouncer just keeps lifting the rope and waving them right through the door, completely bypassing the manager's authority.
That is a highly accurate way to visualize the neurobiology. I mean, the manager and the bouncer operate on entirely different timelines.
Right. The speed difference is crazy.
The striatum fires that reward positivity signal in 250 milliseconds. The prefrontal cortex, which handles executive function and impulse control, takes over half a second, sometimes much longer, to fully process context, like physical fullness and long-term goals.
So the bouncer's always faster. Always. Your ancient brain sees the high-resolution photo of the pastry and reacts to the cue as the most valuable thing in the world in a fraction of a second. Reason eventually understands the value is gone, but the older, faster system has already flooded your brain with the motivation to pursue it.
That timing gap is everything. It really completely strips away the moral judgment we attach to overeating.
It absolutely does.
If the disconnect is a measurable electrical event that happens in a quarter of a second, before I am even consciously aware I am looking at a brownie, then willpower is essentially a myth. Or at least, the way we traditionally define willpower is a myth.
We absolutely have to redefine it, because in this context, the urge to eat is triggered by an environment saturated with high-definition cues, long before deliberate conscious control can intervene.
So the system is rigged.
Oh, totally. The marketers who design food packaging, the developers who build the user interfaces for food delivery apps, they understand this. They may not use the exact term reward positivity, but they design their visual stimuli to bypass the manager and appeal directly to the rogue bouncer. We are walking through a world engineered to exploit a 250 millisecond window of biological vulnerability.
That's a great way to put it.
Glossy billboards, push notifications with little emojis of pizza, the synthetic smell of vanilla pumped into a coffee shop ventilation system. It's a crowded, highly optimized landscape designed to hijack the striatum.
Yes.
So what does this all mean? If my brain is biologically hardwired to work against me every time I open my phone or walk past a bakery, how do I actually navigate that?
It begins with shifting your expectations of what self-control actually feels like.
Okay, how so?
Well, for decades, the popular concept of self-control has been framed as the absence of desire. We tell ourselves that if we just have enough discipline, we simply won't want the unhealthy thing. We try to suppress or erase the temptation entirely.
Right, like being a monk or something.
Exactly. But the data from the appetite study proves that this is a neurological impossibility. That first wave of evaluation, the spike of reward positivity, will always arrive.
You literally can't stop it.
You cannot stop your striatum from firing that initial spark when you are confronted with a highly salient visual cue.
So the bouncer is always going to lift the velvet rope. I can't fire the bouncer.
You cannot fire the bouncer. Therefore, true self-control isn't about preventing the bouncer from acting. Restraint is the ability to manage the gap in time.
Oh, I see.
It is the ability to absorb that initial 250 millisecond shockwave of desire and simply hold your position until the later cognitive processes, the club manager, can step in a few fractions of a second later to assert authority.
So you just have to wait it out.
Self-control is the ability to outlast a signal that your brain is stubbornly, mistakenly generating.
Outlasting the signal, that completely changes the internal narrative. It removes the guilt from the initial craving.
Exactly. You don't have to feel bad for wanting it.
It normalizes the fact that I'm going to feel the pull. My brain is going to register the reward. The victory isn't in achieving some Zen state of not wanting the pastry. The victory is feeling the intense artificial pull, recognizing it as an ancient biological glitch, and allowing the prefrontal cortex the time it needs to override it.
It is the crucial difference between experiencing an internal biological event and taking an external behavioral action.
Right. You don't have to act on it.
Exactly. You can feel the sudden, intense desire for the food driven by that fast electrical spike, and you can just observe it for a moment. You create a tiny window of friction between the visual cue and your physical reaction.
Just a little pause.
And in that gap, your conscious mind catches up,
Yeah.
references the physical data from your stomach, and realizes, hey, my system is actually at capacity. I don't need this.
This is incredibly empowering for anyone listening who has ever felt defeated by a late-night craving.
I hope so.
Like, the next time you finish a massive dinner and someone brings out a dessert menu with gorgeous, high-resolution photos of chocolate cake, and you suddenly feel that intense, impossible hunger hit you out of nowhere, Do not beat yourself up.
No, don't.
You are not weak.
Yeah.
You do not lack moral fortitude. Your fast automatic brain is simply executing a million-year-old survival program that is being tricked by modern visual engineering.
The visual cue is starting the biological engine, but you still have the keys to the transmission.
I love that.
You just have to let the higher-order brain functions catch up to the visual processing speed.
Take a breath. Recognize the rogue bouncer waving the VIPs through. Give your club manager a second to review the fire code and just outlast the signal. The craving is an electrical ghost. It isn't real hunger.
It really isn't. But before we wrap up this deep dive, there is a broader implication to the appetite study that extends far beyond our dietary choices.
Really?
Yeah. The researchers isolated this event-related potential using food because hunger is a universal, easily measurable drive. But the underlying mechanism, the striatum reacting automatically to visual cues of reward, regardless of our conscious goals, applies to almost every aspect of modern digital life.
Oh, wow. You're talking about the architecture of our screens.
Think about the neurological glitch we've just spent time unpacking. If our brains are biologically hardwired to endlessly generate unavoidable, automatic reward signals just from seeing a picture of a brownie,
Which we know they are.
how is that exact same neural pathway reacting to the barrage of other modern cues we face?
Like a smartphone notification ping,
Exactly.
or the red badge on a social media app icon, the infinite scroll on a video feed.
Yes. If your fast-acting brain willingly ignores your physical satiety to chase a visual food cue, consider what it is doing when you are completely, totally mentally exhausted.
Oh, man.
You desperately need to disconnect. You need to sleep. Your prefrontal cortex is begging for rest. But then you see that red notification badge light up on your screen.
And the bouncer is letting the digital ping right through the velvet rope, even when the mental club is completely at capacity.
Precisely.
The striatum spikes with reward positivity because it thinks the notification is a social survival cue, and it just overrides the exhaustion.
It forces us to ask how much of our daily chronic exhaustion is simply our conscious minds constantly fighting a losing battle to override a brain that refuses to stop chasing modern illusions of reward.
Just constant outlasting.
If we have to outlast the signal for a brownie, we are likely having to outlast the signal hundreds of times a day for our devices.
That is a staggering thought to leave on. The glitch isn't just in our kitchens, it's in our pockets.
It's everywhere.
Definitely something to think about the next time your phone buzzes or, the next time you catch yourself staring at a bakery window. Thanks for taking this deep dive with us.